Sample test 1, problem 3. The first problem asks us to solve the following linear inequality. 3x take away the quantity 8x plus 2 is greater than or equal to negative 12. So the main thing you have to remember for inequalities is you solve these like you would an equality, with one little caveat, that if you divide both sides by a negative number or multiply both sides by a negative number, you have to reverse the direction of the original inequality. So let's take a look at this. So let's see here. All right, so we have 3x, and now we're going to distribute the negative sign through. Negative x, take away 2, is greater than or equal to negative 12. Now I'll combine like terms on the left side and get negative 5x minus 2 is greater than or equal to negative 12. I'll add 2 to both sides, so that's not anything I have to even concern myself with because it's adding. Negative 5x is greater than or equal to negative 10. Now at this point, in order to get x all by itself, I have to divide both sides by a negative 5. And when I do that, I need to remind myself that the direction of that inequality needs to change. So I'm going to x is less than or equal to 2. So that's on an interval notation, that's negative infinity, comma 2 with a bracket. That's how you represent that solution set. And to check yourself, you could just take any number less than 2 and put it back into your original equation. For example, 0 is in this interval. It's less than or equal to negative 2. So you'd get 0 minus 0 minus 2. So negative 2 is greater than or equal to negative 12 because it lies to the right of negative 12. Okay, let's take a look at the next one. The next one is a radical equation. I've already got my radical isolated. In other words, it's all by itself on one side of my equation. So to undo the square root, I will square both sides of my equation. Since a square root and a square are are inverse operations, they undo each other, which just leaves me on the left side with the quantity x plus 10. Now I have to be careful that when I square x take away 2, that I don't call this x squared plus 4. We do not use this property for exponents because this is not multiplication between the x and the negative 2, whereas this is multiplication. So what this means is x minus 2 times x minus 2. So on the right-hand side, we'll get x squared minus 4x plus 4. We now have a quadratic equation. So I'm going to put all my terms on one side of the equation. So I'm going to subtract x. I'm going to get 10 equals x squared minus 5x plus 4. Then I'm going to subtract 10 from both sides. And I get 0 equals x squared minus 5x minus 6. And now I can use either my quadratic formula to solve that, or if I can factor it easily, I'll factor it. So let's come on up here. 0 equals x take away 6 times x plus 1. And x minus 6 equals 0 when x equals 6. And x plus 1 equals 0 when x equals negative 1. So remember, whenever you have a radical equation, you need to check both of your solutions in the original equation because we can often get what we call an extraneous solution. So if I try 6, I get 6 plus 10. The question is, does that equal 6 take away 2? So this is the square root of 16 equals 4. 4 equals 4. So that's definitely one of our solutions. However, if I try negative 1 here, I'll get the square root of 9 when I put negative 1 in here for x. but on the right-hand side, I get a negative 3. And that is not, the positive square root of 9 does not equal negative 3, so that is not a solution. So this equation has one and only one solution, and that's 6. The next equation is a quadratic equation. So I need to set this equal to 0. I'm going to subtract 4x from both sides and add 7 to both sides to set my equation equal to 0. I identify, since there are no factors of 7 that add up to 4, I know that I need to use my quadratic equation on this. So let's take a look at that. So I start that equation with another equation, x equals. That always has to be present when you're solving an equation with the quadratic formula. You just have to write x equals once. So let's see, we've got the opposite of b, which is positive 4, plus or minus the square root of negative 4 squared. And since b is a negative number, this must be in parentheses. Minus 4 times 1 times 7, all divided by 2 times 1. So that equals 4 plus or minus the square root of 16 take away 28 all over 2, which equals 4 plus or minus the square root of negative 12 all over 2. Okay, so as you can see, this answer is going to be a complex imaginary number, a non-real number. So we get 4 plus or minus the square root of negative 1 times the square root of 4 times the square root of 3 all over 2. Now I replace negative 1 with I, square root of 4 with 2, and that gives me 4 plus or minus 2i times the square root of 3 over 2. Once I divide 2 into each one of these terms on the top, here's the first term. 4 divided by 2 is 2, plus or minus 2i divided by 2. My 2's cancel, and I get I square roots of 3. There's my answer for C. It's a good algebra exercise to try checking it. I know, pie in the sky, I'm dreaming, right? Okay. How about the next one? This is a radical equation as well, but we've represented the radical as a rational exponent. So your job is still the same. You want to isolate, oops, let me get that. So you want to isolate first this term right here. You want to get that all by itself. So you want to add 32 to both sides. And you get 8 times x to the 2/5. Let me write what we want to isolate in red. So x to the 2/5. That's what we want to isolate. Equals 32. Now I got to get rid of the factor of 8, so I'm going to divide both sides by 8. Now I get x to the 2/5 equals 4. All right. Now how do I undo something that has 2/5 as its power? Well, you could do two different operations if you want. You could undo the square by square rooting. You could undo the 5 by raising to the 5th power. Or you could do both of those things at the same time by taking x to the 2/5 and raising it to the 5/2 power. And whatever you do to one side, you must do to the other. So in this case, we use 5/2 because it's the reciprocal of 2/5. And when you multiply any number times its reciprocal, you get 1 for a power. So that way, we get x to the 1st power. And here we get the square root of the square root of 4 raised to the 5th power. This tells me to take the square root, and this tells me what it always does, raised to the 5th power. So I get 2 to the 5th, and let me see, 2 to the 5th. Oops, but remember, when I take the square root of 4, I get a plus and minus. You see, that's where we're all going to run into trouble. We're going to forget that plus and minus. So that's plus or minus 32. Let me clean that up a little bit for you here so you can see this better. Plus or minus 2 to the 5th. Okay. And if you go back and check this, you can put a negative number in for x because you're taking the fifth root. And you can take odd roots of negative numbers. You just can't take even roots of negative numbers and have it be a real number. All right, let's take a look at E. So E, some of the work was already done for us because this second the denominator on the second side of the equation has already been factored. You could see something like this on a test as x squared minus 4, and then you have to factor it. But as you can see, you have two different prime factors here, x plus 2, x minus 2. So I'm going to multiply everything on both sides, everything on both sides by that quantity up there. So it takes me a little time to rewrite this, but x plus 2 times x minus 2 times my fraction, 5 over x plus 2, plus x plus 2 times x minus 2 times, move that little thing here that I wrote, times my second fraction, which is 3 over x minus 2, equals 12 over x plus 2 times x minus 2. And then I multiply the other side by exactly the same quantity. Because everything on both sides of the equation must be multiplied by exactly the same quantity, or you violated your rules for equations. You have a lot of powerful tools you can use with solving equations. But what I don't want to see is just seeing that 5 over x plus 2 is being multiplied by x minus 2. And that this one is just being multiplied by x plus 2, because that's a violation. You can't multiply one side of your equation by different amounts. So now this is where you've chosen that particular multiple so that each denominator will cancel and become a factor of 1, making your rational equation have 1 in the denominator. So now you have 5 times x minus 2 plus 3 times x plus 2 equals 12. Now, before I go on, I forgot a really important step. Before I even get this far, at step 0, I should have said that these two values cannot be the solution because they make, each one of those numbers would make one of those denominators 0. So if I did all this work and I came out with x equals 2, it would make this denominator 0, which means there's no solution because 3 divided by 0 is not a number. Okay, so let's continue on here. So let's see, I want a little different color. Let's get a purple going in here. Okay, so we have 5 times x and 5 times negative 2. That's 5x minus 10 plus 3x plus 6 equals 12. I combine my like terms and I get 8x minus 4 equals 12. I add 4 to both sides, 8x equals 16. Divide both sides by 8. 8x equals 2. Oh no! X cannot equal 2, so this has no solutions. No solutions. So with all the numbers in the world, there's no way you can find a number and put it in for x so that the left side of this equation equals the right side. Okay, so absolute value equations. And what I want you to keep in mind is that when you have an absolute value equation set equal to a constant, you know that the v, which is your absolute value, and the constant, which is your horizontal line, will intersect in 2 places, which means you will have 2 answers here. So you always have to keep that in mind. So just like with all equations, you want to take the thing you're interested in solving for and get it all by itself on one side of the equation. So this is the absolute value of x plus 1 equals 5, because I'm going to add 3 to both sides. Okay, so this would be like y equals 5 right here, the line y equals 5. I'm too close to the edge there, so I have to move over. This is y equals 5, and this would be like the equation y equals the absolute value of x plus 1. Okay. So I know I mean, this isn't a very accurate picture, but I know there's going to be two x values that make my left side equal, the absolute value of that number is going to be 5. That number plus 1 will be 5. Now, a lot of times you can figure out in your head what that number is, but we want you to be able to show algebraically how to do that. So what do we know about the number on the left-hand side? What we know is that whatever this quantity represents, when I take its absolute value, I get the number 5. So there's two things that quantity could represent. So let's put down 2 yellow blobs here. Here are my two. Notice I'm not changing my yellow blob at all. I'm removing it from the absolute value. I'm keeping its identity the same, x plus 1. And I know if when I come out of this absolute value, I'm 5, that means x plus 1 could have been the number 5, or x plus 1 could have been the number -5, because the absolute value of 5 is 5, the absolute value of -5 is 5. So if I subtract 1 from both sides, I get x equals 4. And if I subtract 1 from both sides, I get x equals -6. And those are your two solutions for F. So those are the problems for number 3 on the sample test. If you have any questions, let me know.